Okay, so many students in secondary are getting confused when it comes to proving uh, certain conditions in geometry. Okay, so statements and reasons is the same as if and then statements. Okay, if there is a condition, then there would be a conclusion. Let's say, for example, if you don't do your homework, you're gonna get punished by your teacher. If you don't follow your mom, you're gonna lose privileges. If you don't sleep early, you're gonna be weak the next day. If you don't train hard, you're not gonna be a better athlete than the others, or you're not gonna be better than your previous self. Okay, so the same with geometry. There should be something or a condition before you'll be able to conclude a certain thing. Okay, when it comes to parallel lines, when it comes to proving lines that are parallel, we have to remember certain conditions. So what do we know about the pairs of angles that are formed when two lines are parallel and cut by a transversal? So let's say you have two parallel lines, and then it was cut by a transversal, you'll be able to form, so the if or the statement should be if two lines are, this symbol means parallel. If two lines are parallel, cut by a transversal, that is our if statement. Okay? Our then or our reasons would be, so if there are two lines that are parallel and then they are cut by a transversal, there will be conclusions that can be made. Okay? We know that when there are two parallel lines with a transversal, then there are pairs of angles that are formed. We have learned previously about the different pairs of angles that are formed when we have parallel lines that are cut by a transversal. What do we have? What pairs of angles do we have? Corresponding angles. What do we know about corresponding angles? If two lines are parallel and they are cut by a transversal, then pairs of corresponding angles are congruent. If two lines are parallel and cut by a transversal, then alternate interior and alternate exterior angles are congruent. If two lines are parallel cut by a transversal, then we have this, we have this, we have this, then we have, what else do we have? Alternate interior, alternate exterior, and same side interior or same side exterior are what? Are supplementary. Okay, so these are the different conclusions that we can come up with if this is a condition. Okay, now let's have some examples. Okay, so here is an example of proving lines that are parallel. You have line A and line B, and then you have this transversal line. You have angles 1, 2, and 3. Given is that angle 1 and angle 3 are supplementary. What do we know about the word supplementary? It means their sum is equal to 180 degrees. Okay? We're supposed to prove that A or line A is parallel to line B. So again, you have to remember what are the different conditions that would say that two lines are parallel. Okay? So first, we always start with writing the given, which is, that's our first statement. Okay? We will write that measure angle 1 plus measure angle 3 is equal to 180 degrees. Where did we get this statement? We got this statement from here. So what will be our reason? This is, reason number 1 would be the easiest one. When I used to teach this, when the kid my student write the first statement and they give the correct reason as they're given, I give them 0.5 point. That's 1/2. It's the effort that counts. Okay? Now, what do we know if the measure of angle 1 and the measure of angle 3, if their sum is 180, then that would be the given. Next, what else do we know? What else do we know? What is obvious from the illustration or from the figure and from all of these statements that you're seeing? First, you have to see other possible things aside from the obvious, which is the given. Look at the figure. What else can you say about the angles? What do you know about them? Correct. Look at angle 1 and angle 2. They are angles on a line. What do you know about angles on a straight line? They are supplementary. Correct. So it will be measure angle 1 plus measure angle 2 is equal to 180 degrees. What will be our reason here? Angles on a straight line are supplementary. Okay, so for me, if my students do not really write the correct theorem name or postulate name, as long as they give the correct statement, that should be acceptable. That should be considered correct, okay? So when I used to teach, I do not ask my students to memorize. I ask them to understand, so that when they give their reasons, they can give the correct statement even without giving the correct name. Because if I give this as a name, I would like this postulate to be called angles on a straight line theorem. The others would say supplementary angles on a straight line, or angles on a straight line or supplementary theorem, something like that. So, but if you say the correct statement, then you will never go wrong. Remember that, okay? Okay, now look at statement 1 and 2. What is common from statement 1 and from statement 2? Measure angle 1 plus measure angle 3 equals 180. Measure angle 1 plus measure angle 2 equals 180. What can you then conclude? I will give you about 5 seconds to think. 1001, 1002, 1003, 1004, 1005. Okay, so you know that this statement is equal to 180 degrees and this statement is equal to 180 degrees. So what can we conclude? We can actually say that measure angle 1 plus measure angle 2 is equal to measure angle 1 plus measure angle 3. Oh, can I just make this measure angle 3 so it will come from statement 1, and then it will be equal to this second one. Since both of them, the sum of these two is equal to 180 and the sum of these two is equal to 180, we can equate them all, or each of them, to 180. What will be our reason? This is common. This is the very simple reason of substitution property. What did we substitute here? Instead of writing 180, we wrote this. Instead of writing 180, we wrote this. So that's why they are equal. Another possible reason could be transitive, okay? If A is equal to B and C is equal to B, then A is equal to C. That could be another possible reason, okay? There are many possibilities in proving, okay? Now, what do we know about this? I will then again ask you to look at statements 1, 2, and 3. What can be a conclusion that can be made? Maybe 5 seconds to think. 1001, 1002, 1003, 1004, 1005. Time's up. Okay. Now, look at this. What's common here? Measure angle 1 and measure angle 1 is common. We can subtract measure angle 1 from here and subtract measure angle 1 from here. What are we going to come up with? We're going to have measure angle 3 will now be equal to measure angle 2. What is an acceptable and possible reason for concluding statement number 4? What is that? Any guess? I actually forgot the reason for number 4. But I could think of what might be a possible reason is that it can be subtraction property of equality, okay? Subtraction property of equality. It means whatever I subtract here, I can subtract here. So that's why I'm left with measure angle 3 is equal to measure angle 2. Now, this is equal to this. What kind of angles are they? I couldn't hear you. What kind of angles are they? They are what? They are alternate interior angles, correct? So just because we're proving parallel lines, we need to have congruence. So we're just going to change it to angle 3 is congruent to angle 2. And the statement or the reason for this is definition of congruent angles. Okay? And lastly, once angle 3 and angle 2 are congruent, then we can say that A or line A is parallel to line B. And this is because of the alternate interior angles are congruent theorem. Do you understand? You can keep on watching this video if there's something that you missed. Okay, this is one good thing about this, learning from the video. Thank you. I'll have more problems later.